My name is Arun Balchandran, and I have been working in the IT industry from 2002 into the areas mainly related to Microsoft technologies and database. And I have been covering the entire gamut of technologies involving database, like the database system where you input the data, and the system where you analyze the data, and the system where you report the data. So through and through, I have been working with Microsoft technology. So you have tools like SQL Server Database Engine, which we are looking at. And then we have analysis services where you have the different models for analyzing the data, like tabular data model and dimension modeling, cube, and then reporting. So this is my area. So we will be covering, this training is called SQL Server Advanced because there are certain basic topics a person should know. And a person who should have worked in these topics for a couple of years so that he comes to the advanced course. So let us look at what are the topics that we are going to cover as part of advanced course. So let us, I'm going to share this. So we have the topic. You can see that Word document. So let us look at from the beginning what all is the requirement and how it goes. So there is a basic SQL Server also which is present, which is there, which will be going in tandem with this. So those who are completely new to SQL Server, I would recommend you start from basic. This is for people who already know SQL Server. So what are the features that we will be looking at? But before we look at, let us see what is the entry profile and prerequisite skill set. So the entry profile and the prerequisite skill set is, you must have knowledge on SQL Server Basic on the following topics, like you have logical architecture, right? Then you have the database design, table design, and you should know how to write SQL statements for insert, update, delete to put data into SQL Server. You should know the query basics like where clause, from clause, select clause, how to filter the data, how to retrieve the data from the database with a specific order, how to retrieve data from multiple databases using multiple tables using joins, how to use subqueries, that means queries inside query, and then T-SQL syntaxes, like I should know what is a variable in T-SQL, how to write comments, how to use if loop, else loop, how to use the while loop. Okay, so if else will give you selection, how to use while loops, what do we mean by case, how to use the case for labeling your data. These are some of the things that would be a prerequisite for this course. Then we look at stored procedures that you should be knowing, how to create a stored procedure, how to alter, how to create a stored procedure with input parameter, output parameter, return type. What is the difference? What is the difference between a stored procedure and a function? What different types of functions, like you should know how to use or how to create scalar functions, how to create table valued functions, how to use them. That is what we are going to see here. But how to create, you should be knowing that basic. Then cursors. How do I retrieve data row by row? Not every time cursor operations are required, but some places cursor operations are required. How to utilize that cursor. Then we go to triggers. So you should know how to write triggers. Triggers are basically small, you can say, business logic, small object which is implementing a business logic for certain pre and post operations. Like I'm going to insert some data, like I withdraw cash from an ATM. Before withdrawing cash, I have to go and check the account balance. So certain basic things are there, and that basic operations have to be done using triggers. And you can also use other rules, like you can use constraints, but constraints are mainly expression based. Triggers are more complex and statement based. You should know how to use them. You should know how to create a view, and also something about indexes and index view. Detail is not required for index and index view, but some knowledge would be good. What is the methodology of this session? Methodology of the session is, it will be a session where we will have concept and then we will have a demo. So the theory session is focusing on conceptual clarity of a particular feature, and the demo session will give the demo for the same. So this is what it is. Now this course, the duration is 45 hours. And the timing, of course, is suggested. It will be 1 hour. It will be Monday to Friday. So it depends. Now, as of now, it is 8:30 to 9:30. That is the timing that we are looking at. And this timing will change based on the discussion. So that is what it is. What are we going to cover? So what are the broad coverages? We will be covering certain features in the database like change data capture. And why do I require change data capture? So there are certain requirements, like a product is there. Product keeps changing its price. Product can keep changing certain aspects. So certain aspects of product change. Certain aspects of, like for example, if I'm looking at a banking system, then I have a product like vehicle loan. I have a product like house loan. Percentage may keep changing. So I need to capture the change data because I want to store the history. Now, why do I want to store the history? Because it is going to be utilized for analysis. Like I want to know what was the previous rate, interest rate, what is the current interest rate, and I have to keep track of both. So therefore, change data capture is very important. Sometimes customer information is changing. So you want to know in the older, what was the old information. So 1 year back, the customer was from Bangalore. Now the customer is from Mumbai, right? Or he is from, if you talk about international audience, so international customer base, he may be from the US. Now he's moved to India. So he is now operating from India. So these changes have to be captured. So we'll see how to use change data capture. We will see how to use common table expressions, which is called CTE. So first we will see what is the problem that you are facing. And then we will see how this feature is going to help me solve that problem. This is the process that we are going to see. Then we will see unpivot pivot. So pivot is basically a mechanism to analyze the data a little more than a group by clause. In a group by clause, the output is in two-dimensional format, a tabular format. But whereas when it comes to pivot and unpivot, it is going to be in cross-tab format. So pivot is cross-tab format and unpivot is the tabular format. So we can change the data from a tabular to cross-tab and cross-tab to tabular. Then we will be talking about table partitions, very important. As a developer in SQL Server, I should know how to store the data in one single table, but internally, how I can use the physical architecture of SQL Server and the logical architecture to store the data from the same table in different file groups, in turn, file groups storing the data into files. So for this, we have to recollect or recap some logical architecture portions, and we will also be covering physical architecture. So we will see how the table partition is created so that the data in the same table can go and sit into different locations. What is the purpose of this? Very easy. If one of the files in one of the location gets corrupted, I will be able to easily retrieve the data still for the data for other locations. So this is the advantage of using the table partition. Like I have branch-wise data. I am storing the account information totally in the database and I am partitioning it branch-wise. Every branch data will be sitting in a different partition, different physical location. What is the advantage? Suppose one of the file gets corrupted. The data for one of the branches I will not be able to access, but the data for other branches I will be able to access. So therefore, This is the table partition. We'll also see index partitions. So for that, you have to understand what is indexing. So we'll look at that. Then we'll look at window functions. Okay. Now window function means what? So I have a group by class. What is the purpose of the group by class? So we create certain groups and we try to consolidate data for those groups. We will see windows function because certain levels of consolidation and certain other operations I do require to create a window. The default window is a group, or there is no window at all. It is the function operates on one row, or sometimes the function will operate on the entire table. How do we create a flexible window, and why is it required also is something that we will see. Then correlated subqueries, it should be known. If you know, then we don't have to cover it here. But if you don't know, it will be a recap and we will cover it here. Then we'll look at apply and cross apply, where I am joining the output of a table valued function to a table. So joins are what we use for joining two tables directly. Here we are going to join the output of a table valued function to a table. This is called apply. So we use apply similar to join, but the only difference is one of it will be a function. So apply, cross apply we will look at. Then we will look at an operation called merge. So basic operations you will be knowing: insert, update, delete. Then what is the purpose of merge? Certain times we have to do all the three together. Right? Like for example, I am inserting a data. It is not simply inserting the data. Suppose the data is already present, like customer data. Suppose the data is an old customer data, then I would have given insert because I don't know whether it's old customer data or not. But inside SQL Server, what SQL Server will do, if the data is already available, it will intelligently understand that the data is available and I should update. So this option is given. And how do you give this intelligence? By creating merge statement. So when you create a merge statement, you will say, if the data is already there for the client, update. If the client data is not there, then insert. So you're trying to do different operation based on the condition. So the application will try to insert the data for the new client, but what you would do intelligently, either insert or update. So that is what merge is all about. Then we will see how to use group by sets. So you would use group by, we will revisit. Whenever we are doing one feature, we will revisit the feature that is required, prerequisite that is required. And if everybody is comfortable with that, we will move on to the next feature. So the prerequisite required is knowledge about group by. Knowledge about cube rollup is really good. And then we have group by set. So we'll compare the difference between cube rollup and group by set. Then with output class. So whenever we are doing an insert, update or a delete statement or use merge statement, with output class will give me the output. Output means it will allow me to access the data before the operation and after the operation, especially for update. And it will allow me to access the data which is inserted. It will allow me to access the data which is deleted. So all this it will allow with output clause. So that we'll look at. Exception handling, of course, how to use try catch. And we'll also see different other options like with results, offset, fetch, throw, etc. So this is the T-SQL features we'll be looking at. But as we look at T-SQL features, for certain features, we require to understand the physical architecture. So we'll look at a basic architectural overview of SQL Server physically, how SQL Server manages memory, right? And there is something called SQL OS, operating system. So there you have the operating system, which is either Windows 10, 11 or server operating system. On top of it, there is a SQL operating system that is there. So how that works. Then how SQL manages memory, the RAM. Okay, and whenever there is less memory, how it is going to swap the data using I/O. We'll look at that. And then we will also look at the SQL Server process scheduling. So this is more theoretical. So it will be just an hour session. And we also need to know how internally data is stored in the table. So we will look at a physical structure starting from what we call as file group, then allocation, partitions, files. So inside file, how the data is stored. And for this, you also need to understand indexes. So we'll look at index structure also. So this is a physical structure. And how will this physical structure help when you're optimizing a query, or when you see a query execution plan, you'll understand what is actually happening internally. That's the purpose of this structure. So we will look at that. We will also look at what are the other modes of storing or other data types which are stored, like file stream and file table storage, etc. So once you look at this, we will move on to locking and concurrency. So in locking and concurrency, main is transaction locking and concurrency. We will see what is the requirement of a transaction. Then we will look at what are the lock that are placed by SQL Server on various resources, like table is one resource, index is another resource, etc. Okay, what are the locks that are placed? So locking concept and mechanics is there. Then isolation levels are there. So what are the different isolation levels? So why do you isolate? When multiple people want to transact, and I want to isolate one transaction from another. And why? Because all of them would require the same resource. Then locking will lead to problem. If I don't lock, it will lead to inconsistency. If I lock, it will lead to blocking. So we have to deal with this with the help of isolation levels. So we will isolate the two transactions using the isolation level and see how it works. We'll be looking at problems like blocking, deadlocks. And in deadlocks also, you have different types of deadlocks. You have like cyclic deadlock is there, conversion deadlocks are there. What are they and how do we solve them? And then we will see a little bit of theory on latches and spin locks. So this is how we look at locking and concurrency. And this is very important. So you can relook at this and you can use them along with stored procedures. So we'll give certain examples where you can use them along with stored procedure. Then we will look at query optimization, the last topic, where we are going to look at how the query processing is done by SQL Server. You write a query select statement. Internally, how SQL Server converts it into an execution plan, right? Then on what basis does it select a particular method of execution internally? So statistics is there, certain other heuristics, certain other information is used, and based on that, it is going to use or finalize a plan called as execution plan. So in execution plan, you will see what are the different steps, what are the different operators, what are the advantages of one operator over other, or rather I could say which operator is used for what situation. And all this knowledge will enable us to understand how SQL Server is processing the query. And in case SQL Server is taking a long time to process a query, where we can modify. So we will see the performance of the query. We will see what are the parameters that can be used to measure the performance of the query. And then we will also see how do we improve our query performance by changing certain aspects of the query and certain good practices. And we'll see how to use hints. Certain hints can be given, how to use the query hints, how to use table hints, how to use lock hints. We'll see different hints. And also we'll see how SQL Server creates a plan, how it stores the plan. We can even freeze the plan, and how the plan helps in further or future execution. This is the plan freezing. How will it help? Whenever a new statement is executed, how it is going to help. This aspect we see in the query optimization option that we have. So it's a 45-hour class. Every day it will be 1 hour each. It will be 5 days a week. So Saturday, Sunday will be off. So this is the point that I just wanted to emphasize. So before we start with the first topic of the session today, I would like to just use the chat window. The chat window is there. So let me use a chat window and also show you the student information form. So there is a student information form URL which I have posted in the chat window. You can look at this form, fill this form, and okay. So you can fill this form, and they will contact you if you want to, continue with the program. We'll have a demo session today and tomorrow. But after that, to continue with the program, you have to make some payment. So you can get in touch with the Go Online Training Institute, and they will guide you as to how it can be done. So this is what it is. So now, I think I will also post it in a notepad so that it is clear. So you have the notepad here. So this is your form which we are looking at. So please go ahead. This link that you are seeing now. Let me share that link with you. Yes, this link is the same link. So people who want to join basics can use the same link to join. To give the information, same link will be used. Just an hour before, we completed the demo for the basic SQL also. That is uploaded. Today's demo will be uploaded, so you can check. So how do I pronounce your name? Okay, how do I pronounce your name? Okay, Chukwumeka is difficult to pronounce, so I just wanted to ensure that I pronounce it properly. Okay, so this is the point that we are looking at. So let us go ahead. Let us see the next aspect of our training. So here we are going to start with the first topic. Just give me a minute. Okay.
Sorry, it's actually Chukwuemeka. You got it wrong. You got it correctly. Sorry.
It is Chukwuemeka. Chukwuemeka.
Chukwuemeka, yes. You got it correctly, yes.
Okay, thank you.
Thank you.
So now let's move on to the Advanced SQL Server Training presentation. So here in this training, the first topic I would be covering is something called common table expression. And I have to share the screen. So let me share the screen. Yes. So in Advanced SQL Server, the first topic we are covering is called common table expression. Sorry. Now, what is the purpose of common table expression? How do we do it? Giving some examples also we will see. Common table expression is basically used for improving the readability of the query. Certain times we have queries in the from clause, we use a table. And many times we use this table again and again within a query. The purpose is we find that it is unnecessary and the query becomes big. It becomes unreadable. So the derived table, which was used when we covered SQL Server Basic, we cover derived table. Derived table means we use a select statement in the from clause. That's called derived table. That's a form of a subquery. And instead of using a derived table, we use a common table expressions. And we will see how to use. There is no temporary table, etc. created. So it is all happening in memory. We'll also see another important feature of common table expression, which is called a recursive common table expression. So let's move on to the common table expression in our SQL Server. So let me share the SQL Server screen with you. So I think I'll share the entire screen so that you can see the SQL Server also. So neat. Now, so this is my SQL Server Management Studio. And in my SQL Server Management Studio, I am connecting basically a query which I already have. So there is common table expression that we are going to see. So the topic we are covering, the first topic given is CDC or change data capture. But the topic that we are covering here is the common table expression, because that is the topic that is more relevant right now to start with. It's a little easy. And then we go on to tougher topics. So that is how I have arranged. So let us assume, like for example, I have a database. I will be using the database AdventureWorks for most of the examples, and a bank database that I have. I use AdventureWorks because the data is already there. I don't have to populate the data. So we are looking at advanced features, so I should not be populating. And of course, we will be using certain other databases as we proceed further. So let us look at this query. So I have this AdventureWorks database. Let me explain the database. If you are new to this database, I'll just explain. This database talks about a company which is selling cycles and cycle-based products, other products like cycle, the clothes that you wear, etc. So that is how it is. So accessories, you can say, cycle accessories. So this is your table, set of tables that we have. And the main table that we focus on for most of the queries is the sales table. You know, there are two tables for sales. One is giving you the header information. That means how for every selling that I have done, what is the information, right? So header information, we call it. So here, let's say I sell it to one of the customer comes for billing. Then I come to understand for that customer, how much is the total money or total sales that customer has made. Now, suppose I want the details, then I have another table which is called order detail. Of course, as we go through queries, I'll explain these, it'll become more clear. So this is like the detail. So given an order, which product he has purchased, what quantity he has purchased. So you can see the order number here, sales order ID. You can see the products, and you can see what is the quantity he has purchased. So this gives me the detail for every sale. So these are the two tables. Right now, what I want is for every selling that I have done, there is a sales territory. So you can see here the table, which is the sales territory table. Okay. I'm going through with an assumption that it is Advanced SQL Server. So I'm not explaining how the table is, etc., what it is. So it will not be so for basic. Basic, it will be slightly different. So here we are looking at the table called sales territory, which will give me the territory for selling. So every sales order in the sales order header, that entry will be, territory will be there. Like whether it is India, whether it's US, whether it's Europe, if it is US, if it is West Coast, East Coast, or is it center? So all this information will be present with respect to selling. So what is the query that I am trying to tackle? So we are going to see what is the problem that we face and how common table expressions, which is otherwise called CTE. CTE means common table expression. Okay. So we are going to see how these common table expressions are going to help us solve certain problems that we face. So let's take an example. I want the territory with maximum number of orders. Right. So how do we get this information? So like, for example, what we want is territory and the number of orders. So to write this information, okay, no problem. Basic, yes. Yes, so yes, you can log out. So you can join the basic, you can check the demo session. Tomorrow there is a second demo session for basic SQL Server from 7:30 to 8:30. These are the demo sessions. The timings you can always get back to, go online and check what is your preferable time. Recording is available for today's demo as well. Okay. So this session, now let us move on to the next aspect. So we are looking at, I want the territory with maximum number of orders. So we already know how to get this information. The sales territory is there. So you have the select territory ID, count, sales order ID as number of orders. So here you have territory wise number of orders. So this is like a group by class. It's very easy to get this information. So I get this information for my query. Okay. So I have territory wise number of orders. Step 1. Now, what if I want territory wise minimum number of orders and maximum number of orders? You can see here. So welcome Shahul. We just started with the introduction for Advanced SQL and we are going through the first topic as part of this demo session. It's common table expression. So what is it that I want ultimately in this query? I want the territory with maximum number of orders. So how do I get this territory with maximum number of orders? This is how you get territory with number of orders. So we have already seen this aspect. So you get territory wise number of orders. Okay. Now, after this, the next step is I will use this and I will perform an operation where I will get a territory with maximum orders, because what I cannot do. So it's not possible for me to say I want max of count. Why is it not possible for me to say I want max of count? Because max is an aggregate function, count is another aggregate function. So both aggregate functions I cannot nest. So nested aggregation is not allowed. So you can see if I execute this function here, so you can clearly see it says cannot perform an aggregate function on an expression containing an aggregate or a subquery. So this is not possible. So I cannot do it in one shot. So how do I do it now? So I have to first count the number of orders, and after counting the number of orders, I will have maximum number of orders. Okay. So maximum number of orders, we will now see how we do it. Select, okay, maximum. Here it will be number of orders. So we will use the same number of orders. Okay. And we will say as maximum orders and maximum number of orders. And then in your from clause, we will have this entire query. And we will say as, say, territory wise orders. Okay. And this maximum number of orders that you get, you can clearly see. So at one level, you are counting. At the other level of the query, you are getting the maximum orders. So this is how we use a subquery. So you would have used the subquery. Of course, I should not have an order by clause. So let me remove the order by clause in the inner query. And this is how I will get maximum number of orders is 6,843. Which territory, how to get that, we will see a little later. This is how you get the maximum number of orders. So now the first question is, I have this from clause. It is giving me the select statement. You can see here. So the query is a little unmanageable with respect to reading. So what we do, one option for us is to leave it as it is and see, okay, how it goes. So now let's make it a little more interesting. So now I want territory with maximum number of orders. That means I should have the territory ID as well as the number of orders, which is maximum. How do I get that? So we now play one more subquery. So what is that one more subquery? We will see that here. So we have to say select. Okay. I want the territory ID. So I want the territory. Then I want to count, or I want the maximum number of orders also. I have the maximum number of orders, or you can say number of orders for the territory. And from which table? So now I have this option. I have a select clause which is already giving me territory wise number of orders. So I use that here from clause, and I say as territory wise number of orders. So now it becomes territory wise number of orders. And then in my where clause, I will say where the number of orders which I'm getting has to be equal to. Okay. And here I'm using a where clause which gives me the maximum orders, because I know this is going to give me the maximum number of orders. So I say select max territory wise. So this is giving me maximum number of orders. So I am comparing it in the where clause with the number of orders. So this will help me get territory wise maximum, or territory which has maximum number of orders. And similarly, I can also get minimum number of orders. So I can use an AND clause here. And I can just repeat this same where clause where the number of orders is. So and, or in fact you use or here, because one of the two, minimum or maximum, and you use or, and you have the number of orders. Here I will use minimum. So now this is one query. You slowly see it is getting complex, and we will see initially we said there's only one subquery, etc. But now it's getting more and more complex. So you can see that in this case, I'm going to get the information, and here I can see territory with maximum number of order is territory ID 9, 6,843 orders. Territory ID 2, minimum orders 352. So you can see now the query is quite complex as far as readability is concerned. Okay. Now this is where the requirement of common table expression comes. So what is this common table expression? You go to this query. Let's take this query for example. This select territory ID and count of the number of sales. Territory wise count of sales. This is the query. Territory wise number of sales. Now what I do is, using this feature of common table expression, this whole query, I don't write it multiple times. So what I do, let's see here. So I use a common table expression. So we say with territory wise number of orders. This is the name of the CTE, with territory wise number of orders. Okay, CTE. CTE means common table expression. It is given, you can either use CTE before or we can use CTE later. So we will use it before, that is the norm here. So we use it. Okay. So with CTE. So this is how we use the common table expression. I'm just checking for. So with CTE in here. And what is the common table expression going to give? Common table expression is nothing but an expression which is the output of a select statement. And in this statement, you want the territory ID and the number of orders. So it's going to give me the territory ID. So this tells me what is the output that I'm going to have. and then you have number of orders. Okay. So both of this you have territory wise number of orders as, and then you open the bracket and you close the bracket. Okay. And then you have this whole select a territory wise number of orders. So you have this, and then you start using it in your select statement. So instead of saying select from and the entire query, I simply say select CTE or select from the territory wise number of orders. So now it becomes very easy, and this territory wise number of orders I can use in multiple places here. So here also you see it is select from, and it's the same query, territory wise number of orders. So here I will use the from clause and get this territory wise number of orders. So this is the common table expression I would be using. So from where? Okay, from territory wise number of orders. Okay, or so you are going to select from territory wise number of orders, or again number of orders equal to. So again here we have the option of removing this whole thing. So unnecessarily I will be using minimum, I'll be using this particular point. So I will use a from clause, and instead of saying from, again I use here territory wise number of orders. So now if you look at the entire select statement, the select statement becomes much more simpler, of course, and you can see that I am using a subquery in the where clause, but it becomes easy for me. I am not repeating this particular query. Which particular query? This query which is there giving me territory wise sales. This I am not repeating in my main query. And inside my main query, I use this common table expression. So now I execute this together, and you can see this main query is used multiple times in my select clause. So I have this incorrect syntax near select. This is not required, comma is not required. So execute, and then I get this same information. So it becomes easy. I separate out this query. So what is it doing? The first thing we said, it's improving the readability. Now your question will be within the query, where is within the outer query, which is giving me minimum orders and maximum orders, right? Within this query, you are calling this inner query multiple times using the common table expression. Where is the data of inner query stored? Is it going to be executing this query every time? Answer is no. Within the query, when it is getting executed, the output of this query will be stored only once, and it will be repeatedly used whenever it is required in the outer query. So here the select territory ID count is executed only once, the first time. And now the second time, because I'm referring to the same common table expression, it will refer to that output automatically. This saves also the number of times you're executing the subquery unnecessarily. Of course, if you don't do it, SQL Server does it. SQL Server uses something called a spooler to internally store the data. He understands that you're utilizing the same query multiple times. Therefore, there is no much difference as far as performance is concerned. Therefore, CTE is more suitable for increasing the readability, making the query more readable and more easy. You yourself can see a query with so many select statements, same select statement repeated multiple times, and now that select statement is encapsulated in a common table expression. This is how, this is the first important benefit of common table expressions. We will see certain other operations of common table expressions in tomorrow's class. So today we stop here, but before we go, before we close the meeting, I am again going to give the student information link. It will be present in your chat box. Those who are interested in continuing with the session. Of course, tomorrow's session is also a demo session. You can continue. But after that, if you want to continue, you give your student information link. You'll have to register for the course and pay for the course, whatever is the payment. The student information link is given in the chat box, and I will also give it in the notepad. So please note down, Shahul and Sandeep, you can note down this information and you can then fill in, and they will contact you. That time you can specify what are your preferences if there are any. So with that, we complete today's class. This demo class also is recorded. So I think Shahul entered late. This is a SQL Server advanced course demo. Basic was done in the previous hour, 7:30 to 8:30. This is an advanced course demo. So the recording is available, so you can go ahead and see the information.
Yeah, okay. I will record.
Okay. Yes. Any other questions, Sahul and Sandeep?